Hello, my amazing students. This is Mrs. A, and we're going to do 4.3 in Messer-Smith's Intermediate Algebra tonight. I've been going through this in class. Some of you are saying that I talk too fast, and I probably do, because I have a certain amount of material that I have to cover every class. But that's why I make the little videos for you. Remember that there are PowerPoints online. On your D2L shell, there are little student guided notes online. And then I'm putting these little videos online to help you. Where I go too fast, you are certainly able to rewind and do it over and over again on the video until you grab the concept. So I am going to go through 4.3 tonight. Now remember, when you sign in, 4.3 is going to be an extra credit. Now 4.1 was a grade. Everybody was supposed to do 4.1. 4.3 is going to be an extra credit because we actually did cover it in class. And if you got it in class, you don't need to listen to the notes. But if you were one of those students that was saying, hey, Miss A, please slow down, then this is for you. Okay, so remember to sign in, just like I showed you before, hi and bye, hi at the beginning of the video, bye at the end. And then if you're in my 12:30 class, you put a 12. If you're in my 9 o'clock class, you put a 9. Your first initial, your last initial, and the last 2 digits of your student number, your college student number. And then, of course, remember to take ample notes. Because when you take your quizzes in class, you're allowed to use your notes, but not your textbook. Because I'm allowing you to use what you have actually studied. So take some notes. You may bring the notes to class with you. Remember, on all quizzes and tests, there are no cell phones. So you don't want to put your notes on your cell phone. You need paper notes. Okay, and tomorrow you should expect a quiz on 4.1, 4.2, and 4.3, but our quizzes are very small. Okay, you will only have 1 or 2 problems from each section, and that's it. So remember, the quizzes don't count a lot. They do count, but not a lot. So it's kind of to get you used to taking test in class again. Some of you have been out of math for a while, and just kind of to get you used to taking tests again. So here we are going to start with 4.3. Okay, so we are talking about writing an equation of a line. And like I told you in class, writing the equation of the line is just a little bit higher level of thinking than being able to take an equation and graph it, okay? Because now you're having to come up with the equation. You're not given the equation and told to do something with the equation. Now you are the one that has to come up with the equation. So we're going to have several different strategies of how we're going to do this. So they're going to break this up into different scenarios so that you can know what to do when you're given each one of these scenarios. So the first one is write an equation of a line when you are given the slope and the y-intercept. Well, we have talked about the slope-intercept form of the line, which is right here. Y is mx plus b. And it just makes sense that if we're given the slope and the y-intercept of the line, we're going to use the form of the line that has a slope. Remember that slope is m, and a y-intercept. The little b stands for the y-intercept. So we're given the slope and the y-intercept, so certainly we should use the slope-intercept form of the line. This is one of those line formulas that should be on your special study sheet for your quizzes and your test, because you will use this one over and over. And then we're just going to take the values that they give us and substitute into the equation as this example, number 1, suggests. If we're given a slope with a -5 we're going to find the equation of the line that has a slope of -5 and a y-intercept of 0, 9. Now remember, to find the y-intercept, we let x be 0. Now let's just look at a picture of that. So here is our little coordinate grid. Remember, this is the x-axis. This is the y-axis up here. Oops, let me move this up back a little bit. Okay. And the y-intercept is where we cross the y-axis. So I'm going to draw a little line here. Okay. And the y-intercept is where we cross the axis, which, hold on, okay, it's going to be right here. Okay, so that little point right there is the y-intercept. It is where the line crosses the y-axis. Now remember, it's your x-coordinate that goes left or right. And you're straight up on the line. So your x-coordinate is going to be 0, and maybe your y-coordinate for that point will be about 2. Okay, so we will label this point 0, 2, and that is our y-intercept. So here we go back to our little PowerPoint here. So now this y-intercept is 0, 9, which means it's going to cross, this line is going to cross the y-axis at 9, and then it's going to have a slope of -5. So here is our slope-intercept form of the line, already set up to receive a slope and a y-intercept. Because our slope is -5, we say m is -5. Remember, that's the letter we use to signify slope. And b is the letter we signify the y-intercept with. So the y-intercept is 9. And we just plug in the -5 and the 9 to get an equation of the line. Okay, so we already have a form of the line that's already set up to receive slope and y-intercept. Now, what happens? Scenario 2. We have an equation of a line. We're seeking an equation of a line when we are given its slope and a point. Okay, any generic point. All right, so we're going to let our slope be. Now, notice this little difference here. Okay, we have just a tiny little difference here. I'm going to put our slope formula up on our little whiteboard here. Okay, so here's my little whiteboard. And my little whiteboard, y is, or m, excuse me, m is y2 minus y1 over x2 minus x1. Remember, that was 4.2. And that equation was our slope formula. Now look at what we have here. What is different between this equation here and this equation here? Okay, let's put them side by side. Can you see them? All right, so the difference is that this one has a y2 and an x2, and this one just has a y and an x. All right, now look at the picture. Okay, here they're saying this is the given point, and this is some other point. Okay, it's another point on the line. It could be any point on the line, but it is going to solve the equation. It is on the line, but it's not a specific point that you are given. So they don't call it x2, y2, they just call it xy for some generic point on the line. So that is the only difference between our given slope formula here and our formula here. They have just taken out the 2's, okay? And now they've said, all right, this is a generic point, and then this is the given point on the line. Now, if they take this equation and they cross multiply, remember, anytime I have a number, I can put a 1 underneath it, okay? So I'm going to put a 1 underneath my m, and I'm going to cross multiply. When I do that, I have 1 times y minus y1. And on the right-hand side, I've got m times x minus x1. This is called the point slope form of the line. Okay, the point slope form of the line. Okay, and that's what you have here. This equation results in a cross multiplication of this. And all they did between here and here is switch it around. Okay, so they just turned them around in the mirror. Okay, so now let's go on to the next slide where we're going to see the formal point slope formula, which is just what we had on the screen. And they're saying x1, y1 is a point on the line. That's the given point. And m is the slope of the line. So if you're given a slope and a single point, you want to use the form of the line that is developed for a point and a slope. Okay, the slope and a point on the line. If we are given the slope of the line and a point on the line, we can use the point slope formula to find an equation of the line. So here we have, notice it says the point slope formula will help us write an equation of the line. We do not usually express our final answer in this form. We will write our answers in either slope-intercept form or in standard form. Remember, I told you in class that you want to make sure that you know how to turn all of your equations around into another form so that you don't lose any points on the test, right? We have to be looking for what they tell us to put it in. Now notice what they put here. A line has a slope of -3 and contains a particular point, 2, 1. Find the standard form for the equation of the line. So we're going to use our slope, our point slope form, and then we're going to turn that into the standard form. Now I'm going to do it for you on my little piece of paper, and then I'll show you what they're going to do. Okay, because they're going to do the same thing I'm going to do. But it tells us that we have a slope of -3, and we have a point that is 2, 1. The point is 2, 1. All right, and the equation that we're going to use is the point slope form of the line. Y minus y1 is mx minus x1. Okay, so now we're going to plug in our -3 for our m. And we're going to take the 2 and the 1 and put them in the place of our specific point. So 2 is going to go here. And the y1 is going to be 1. Notice that minus sign was part of the equation and is not going to become a plus sign. That was a minus sign in the equation, and all we did was substitute in the x1 and the x2. So now that is an equation of our line. It is not, however, the standard form. Remember, the standard form is going to be ax plus by equals c. That is the standard form of our line. So now we've got to get this into a form that looks like this. The first thing I'm going to do is what? What is it when I take this 3 and take care of that parenthesis? That's called distribution, isn't it? So when I write this over again, it's going to be y minus 1. And then it's going to be a -3 times x, or a -3x. And a -3 times a -2 is a +6. Okay, we're getting closer. This is a minus here. It's hard to write on this board because I've got a camera in between me, okay, and the computer. But we want our x and y on the left, don't we? So this -3x needs to be moved to the other side. So I will add a 3x, and I will add a 3x to the other side, all right? And, of course, an x and a y don't add, so I'm going to put them 3x plus y minus 1 equals 6. Almost there. All right, so I need to get this 1 taken care of. So I'm going to add a 1. And I'm going to add a 1. And I'm going to wind up with my equation being 3x plus y equals 7. 3x plus y equals 7. All right. Now they're going to do it a lot neater than I did, but I must have clicked on something. All right, so let's see what they do. All right, they ended up with 3x plus y equals 7, didn't they? And they did the same steps I did. They just did them a little bit neater. So that is how we're going to do it. We've got the equation that has a slope of -3 and a 0.21, but we have put it into standard form. All right, so now, scenario 3. Okay, write an equation of a line given 2 points on the line. So now we have 2 points. We don't even have a slope. So this is going to be a two-part process. First, we're going to use the 2 points to find the slope of the line. And then we're going to use the slope and one of the points. Notice I can use either one of the points to get it into the point slope formula. Okay? Now, let's see how we're supposed to leave this one. We're supposed to leave this one in slope-intercept form. They're giving us 2 points, and we have to come up with an equation of a line in slope-intercept form. Okay, so the first thing I'm going to do is I'm going to do it for you, and then we're going to see their solution so that you see me work through it a little bit slower. 6, 4, and 3, 2 are the points. Okay, so 6, 4, and 3, 2 I've written at the top of my screen. Okay, so step 1 was to take the 2 points and put them into the slope formula. Okay, so we have m is y2 minus y1 over x2 minus x1. Remember, my y's always go on top and my x's always go on the bottom. And remember, it does not matter which point I choose to be point 1 and point 2. I just have to be consistent. Okay, so I'm going to let this be my y2 here. So I'm going to have a 4 minus a 2 on the top. And I'm going to have a 6 minus a 3 on the bottom. Okay, so now when I take care of this, it's going to be 4 minus 2 is 2 over 6 minus 3, 3. My slope is 2/3. Okay, so now we're going to take the slope in one of these points to come up with the equation of the line. Now I'm going to cheat a minute because I'm going to come over here and see which point they used. Okay, they're going to use the 6, 4. So I'm going to use the 2, 3. Okay, so we're going to use the point 3, 2, excuse me, to do this, and then we'll see how they did it with 6, 4. We should come up with the same answer. Okay, so we're going to use the 3, 2. We have a slope and a point, so we're going to use the point slope form of the line. Y minus y1 is m x minus x1. Okay, this is one of the formulas that you want to be written on your little special study sheet. Now remember, you can't use your study sheet on a test, but you certainly could use your study sheet on a quiz. Okay, so now we're going to slide these in. Slope is 2/3. So here's my slope being replaced with 2/3. My y value is 2. And my x value is 3. Okay, and now we're supposed to leave this, remember, in the slope-intercept form. So we got a little work to do on this. First of all, let's get rid of this parenthesis. So we're going to distribute this, and we've got y minus 2 equals 2/3 x take away, and 2/3 times a -3 is a -2 because my 3's will cancel. Okay, so I'm trying to get this into slope-intercept form. So I'm going to want a y by itself on the left-hand side. I'm going to add a 2, and I'm going to add a 2 on the other side. Always do the same thing to both sides. So my -2 and my +2 and my -2 and my +2 will cancel, and I will be left with y is 2/3 x. Now let's look at what they got. Y is 2/3 x. They did the same process, but they used the other point. Okay, so does it matter which point you use? No, you use one or the other of the points. You have to use both points to find the slope, and then you use one or the other to find the equation. Okay, so now remember in class I showed you another method that works quite well, and some of you looked at me like I was crazy, but we're going to show you that other method, which is basically using the slope-intercept form of the line to find an equation when you're given a slope and a point. Okay, so here is my slope-intercept form of the line. Y is mx plus b. Okay, you say, but I don't have a y-intercept. I just have a generic point. And that is true. Okay, we don't have this b. But we do have a slope. So we're going to take the 2/3 and we're going to put the 2/3 here in place of the slope. And although we don't have a y-intercept, we do have a point that is supposed to lie on the line. And if it lies on the line, it is a solution to the linear equation. So I'm just going to take that 3 and I'm going to put it right there where the x is. And I'm going to take that 2, which is my y value, and I'm going to put it right there where the y is. Oh, excuse me. That was supposed to be a 3. 3 and 2 to replace the x and the y. So now 2/3 of 3, remember the 3 is 3 over 1, so the 2 3's will cancel each other, and I wind up with 2 plus b is 2. Well, 2 plus 0 is 2, so that means my b, or my y-intercept, is 0. So now I'm going to go back. Y is mx plus b, but now I've discovered that my b is 0, and my slope was 2/3. Okay, and so y is 2/3 x plus 0, but I really wouldn't put this 0 here, would I? I would leave it off because plus 0 doesn't mean anything important. I'm just going to leave it off. And guess what? I come up with the same equation that I did using the point-slope form of the line. Okay, so if you do forget your point-slope form of the line, just remember you can use your slope-intercept form to get the same job done. Very, very handy. Okay, so now we're going to move on to scenario 4. How are we going to come up with equations of the line when we have a horizontal line or a vertical line? Okay, so remember, we've talked about this quite a bit. A horizontal line, well, it doesn't look very horizontal, does it? Okay, a horizontal line, the points on the horizontal line have the same y value. Okay, so this point might be 0, 5, and then this point might be 4, 5, and -4, 5. Okay, remember the y is the height of the line. So if you have a horizontal line, aren't all the points at the same height? So since the y's are all the same,
This is a y line. Okay, so y equals, well, all of the y's equal 5. So this is a y equals 5 line. Remember, I also gave you the hint that y cuts the y. I can't write here. Y cuts the y axis. All right, remember, here's your y-axis, and a y line cuts that axis. All right, so that is how you find a horizontal line is a y line. And then when we have a vertical line, okay, a vertical line has points that are all the same distance to the right or to the left of 0, 0. So their x value is the same. So if I had 3 points, this might be 7, 5, 7, 3, 7, 1. Okay, all of the x values are the same. And then if we look at our other little hint, remember that x lines cut the x-axis. Okay, x lines cut. This is the x-axis. X lines cut the x-axis. So this is vertical. Okay, so vertical lines are x lines. X equals 7 is the equation because all of the x's are 7. So this little slide is reiterating that point. If we have a horizontal line containing a point, AB, since horizontal lines have the same y value, then we take y is b. And if we wanting the equation of a vertical line, then all the x's are the same, so x is a. So it's just depending on which one you're going to pick, depending on whether it's an x line or a y line. So here we have a horizontal line. Horizontal line is a y line, so we're going to pick the y value of the point, stick it over here. Y is equal to -4 is the equation of the line. Okay, so now this is a summary of all of the different types of scenarios that you could be given. This one is the first one. Again, the slope and the intercept is given to you, so you will use the slope-intercept form of the line. When we have a slope and a single point, we will use the point-slope form of the line. Okay, this is the scenario that I showed you. You could also use the slope-intercept form if you wanted to. It's just kind of a little shortcut. 2 points, you're always going to have to find the slope first and then use either point and then your horizontal and your vertical. Now, we're talking about parallel lines and perpendicular lines. Now, parallel lines are like railroad tracks, okay? They are the same distance apart all the way through every place that you could measure. The distance between is going to be the same. If a railroad track, if they weren't parallel, then the train would be in trouble because you'd have some places that were wider and some places that were narrower. It would not work very well. So think of railroad tracks when you think of parallel. Now look at these two lines, line 1 and line 2. What do they have that is the same? They have the same slope. Okay, so here's our formal definition. Parallel lines have the same slope but different y-intercepts. If two lines are vertical, they are parallel, however their slopes are undefined. Okay, so basically we can have two vertical lines, they are still parallel, but their slopes are undefined. Okay, perpendicular lines, let's look at the relationship between these two perpendicular lines. Perpendicular lines make a 90-degree angle or a right angle, so this could be a little box there showing that you have 90 degrees. Okay, now let's just look at these two lines. They've given us two equations. 2x plus y is 4, and x minus 2y is 6. Okay, now in the class, I gave you a little tip on that sometimes you're given something in standard form and all you care about is the slope. Okay, so we're going to do that little development that I did before. Let's start with ax plus by equals c. Okay, again, this is a little bit extra. It's a little bit of a shortcut. If you don't understand it, you don't have to do it this way, but it does make things much faster if you can remember it. So I'm starting out with a general form, standard form of the line. In other words, I've got an A and a B and a C instead of numbers like you see up here. Okay? Because I'm starting with the general form, the rule that I come up with will be true always. Okay, so I'm going to develop a formula. So on this one, if I were going to take this standard form and I'm going to say, well, I want to put this standard form into slope-intercept form. Slope-intercept form, remember, is y is mx plus b. Okay? So if I want to get it into this form, I just need a y by itself on the left. I don't need this x over here. It's got to go to the other side. So I'm going to subtract an ax from both sides. Okay? I'm trying to get my y by itself on the left. Now what do I have now? Ax take away ax is just 0. So I'm going to have a by on the left. And then on the right, I've got a negative ax and a c. So I'm going to put, since I'm trying to get here, I'm going to put the negative ax in the front. Negative ax plus c. Okay, so now I just want a y. I don't want a by. So I'm going to divide everything on both sides by a b. Okay, so I'm going to divide by b, divide by b, divide by b. So now I have y is negative a over b x plus c over b. All right, now notice what my slope-intercept form is. When I have my equation of the line solved for y, it is in slope-intercept form. My slope is the number that is in front of the x. So guess what that negative a over b is? It is my slope. And my y-intercept is the constant. That means it doesn't have a variable. So that c over b is my y-intercept. Okay? So the rule is always going to stand. If I start with something in standard form, knowing that the x term, the coefficient, the number in front of the x is my a, the number in front of the y is my b, and the constant on the other side is my c, then I will always know that my slope would be negative a over b, and my y-intercept is c over b. Okay, let's see how this works. I go up here to this equation, and this is my a, this is my b. Oops, there's nothing there, so it's going to be a1. Okay, and then this is my c. So a is 2, b is 1, and 4 is c. Okay, so now my slope is negative a over b. Negative a over b is, in this top equation, here's my a, 2 is a, so negative 2 over 1. So the slope of this line is negative 2. Then I look at this line here. Okay, it's in standard form. X is first, then a y, and on the other side is my constant. So the slope is negative a over b. Negative a, oops, there's nothing there again, so it's a 1. There's a 1. So negative 1 is my negative a. And here I've got my b is a negative 2 because my equation is a positive. So that's a negative 2 is my b. What happens when we divide a negative by a negative? We get a positive. So the slope of this line, the second line, is 1/2. Okay, so now let's look at those. The top slope was a negative 2, and the bottom slope was a 1/2. Negative 2 and 1/2. All right, so now we did it a different way than they're going to do it. Look at the two lines that they have. Okay, we have the same lines. Look at the next page here. They're going to take the first one here, and they're going to turn it around into slope-intercept form to find the slope. They said the slope is negative 2. Well, we found a negative 2 also. Okay, the second one, they turned it around into slope-intercept form to find out that the slope was 1/2. Okay, so both methods are correct. It's just which one you want to use. The shortcut, or do you want to turn them into slope-intercept form to find out what the slope is? In any case, what is the relationship between these two? We saw at the beginning that they were perpendicular. We have a negative 2 and a 1/2. The relationship is that they are opposite signs and they are flipped over. They are reciprocals of each other and they are negatives of each other. So when we have perpendicular lines, our slopes are negative reciprocals of each other. Okay, so here's our definition. Okay, when neither line is vertical, perpendicular lines have slopes that are negative reciprocals of each other. All right, so here we have 3 different little systems here. We're trying to figure out whether they are parallel, perpendicular, or neither. Okay, so in class, I had you do these, and then I came back with the answers so that you could see them. Okay, these, when we find out the slopes, notice that if I take this line here and I multiply it by 3, guess what I get? I get that 3x plus, now the y-intercept's not the same, but the slope is the same. Okay, remember the slope is negative a over b, so this slope is negative 3 over 6, which is negative 1/2, negative 1 over 2. So the slopes are the same, therefore this one should be parallel. Okay, and then these are going to be what? If you take negative 2 over negative 7, you get 2 over 7. If you take negative 21 over 6, you get negative 7 over 2. So they are negative reciprocals. Okay, and then this one we showed you in class winds up being neither. So let's see the PowerPoints on each one of those. Okay, so this is A, and they're grinding through to show you the slope-intercept form of each one and getting the slope to show that they are parallel. On B, you're showing that the slopes wind up being the flip, the reciprocal, and opposite signs, so they are perpendicular. Now on C, we already have one of them that is in slope-intercept form. So they're only going to have to put the other one in slope-intercept form. And they are going to get, okay, the slope for one was negative 7. The slope for the other one was 7. Therefore, they are neither parallel nor perpendicular. Okay, so now it says write an equation of a line that is parallel or perpendicular to a given line. So a line contains point 42 and is parallel to the line y is 3 halves x plus 2. Now we only care that it's parallel to this line. So the only piece of information we need from this line is its slope. Since it's in slope-intercept form, we know the slope is joined with the x. So we have a slope and a point, and we know how to deal with that. We're going to use our point-slope form of the line, put in our slope, put in our point, crank it around, and turn it into the form that they told us to use, which is the slope-intercept form. So now you can see the parallel line going through 4, 2. All right, so now example 7, find the standard form for the equation of the line that contains the point and is perpendicular. Okay, now we're going to do this 2 ways. Okay, first of all, I have to find the slope of this line. That's the only thing I care about on that line. So my line is 5x minus 2y equals 6. Okay, so I'm going to do it both ways. If I'm going to turn it into a slope-intercept form, I need just a y on the left. So I've got a negative 2y. I'm going to subtract the 5x here. I'm going to subtract the 5x on the right. Okay, so here's my little line. I get a 0 here, minus 2y. I want my x to be first, so we'll put that first, plus 6. Okay, so now I don't want a negative 2y, I just want a y. So I'm going to divide by negative 2, divide by negative 2, divide by negative 2. And I wind up with y is negative divided by negative is a positive. 5/2 x minus 3. Now remember, the only thing I care about, because it's perpendicular to this line, the only thing I care about is this right here, the slope. Okay, so the slope of this line is 5/2. So the perpendicular slope, we usually use a little symbol like this to talk about the perpendicular. The perpendicular slope is going to be what? 5/2. I flip it over and take the negative, so negative 2/5. Okay, so that is the slope that we're going to be looking for. Or I could use the other method, which is realizing that this is in standard form. 5x minus 2y is 6. So this is my A, and this is my B. So the slope of this line is negative A, so it's going to be negative 5, over B, which is a negative 2. So the slope of the line is 5/2. The reciprocal slope is negative 2/5. Okay, so got the same thing, a little bit less work, using the negative A over B little shortcut. Okay, so now I have a point, and I know that the slope I desire is negative 2/5. Okay, so they're going through the process of getting it into slope-intercept form to find out the slope of this line was 5/2, just like we did, and the perpendicular slope is negative 2/5. Okay, which is what we had. We had negative 2/5. So we're going to take that and the point that they gave, and that's what they're doing here. They're putting it into the point slope form of the line, and they're cranking out their standard form. Okay, now there is another way that you could do this. Remember, I showed you that when you have a slope and a point, you can use the slope-intercept form of the line. So while they did it that way, which is correct, I'm going to do it for you using y is mx plus b and the slope, which was negative 2/5. Okay, so we're going to look at both of these side by side. This is the other method. We're going to just use this form. We don't have a y-intercept, but we do have a point. So we're going to take our slope-intercept form of the line. Y is Instead of the m, I'm going to put in the slope I'm desiring. And then I'm going to take the point, which is supposed to lie on the line. I'm going to put the x value here, -5. And I'm going to put the y value over here, 3. Okay? Now, when I do this, I'm going to wind up with the 5s. I'm going to end up with a positive number because I have a negative times a negative. I'm going to get a positive number, and the 5s are going to cancel, so I'm going to wind up with a positive 2. Plus b is 3. Well, 2 plus what is 3? B is going to end up being 1, isn't it? So the b is 1, which means that the equation of my line is y is, my slope was -2/5. I'm going to go back and grab it again. X plus 1. Okay? Now, they told me to put this in the standard form. I have it in the slope-intercept form. To get into the standard form, I should multiply. Remember, standard form has no fractions. So I'm going to multiply everything by 5. So 5y is equal to -2x plus 5. I have to multiply every single term by 5. And now I need my 2x to be on the other side, so I get 2x plus 5y equals 5. 2x plus 5y equals 5. Okay, so both of those methods are correct. Okay, I did it using the slope-intercept form, and they did it using the point-slope form. And they are both correct methods. The key is we're going to get it into standard form when we're done. So whether you use this method over here or whether you use the one on the board, we have to get it into the desired form when we are done. Okay, there's theirs, and there's mine. Okay, if you need to look at it longer, you can just pause the video. Okay, so then the last thing is write a linear equation to model real-world data. So here is a situation where they're talking about sulfur dioxide emissions in the United States have been decreasing by about 1,080.5 thousand tons per year. So this is starting in 1998. So 1998 is going to be our 0 year. In 2000, approximately 16,636,000 tons of the pollutant were released into the air. And we are to write a linear equation to model this data. We're supposed to let X represent the number of years after 1998 and let Y represent the amount of sulfur dioxide in thousands of tons released into the air. Question B is how much sulfur dioxide was released into the air in 1998 and in 2004. So here's our solution. Notice that this has been what's happened every year. So this is our slope, okay? And then we have points, okay? We had the value, a point on the line is 16,636. And they're saying 2000 corresponds to year 2 because it is 2 years after 1998 when the problem started. So they have a point and they have a slope, so they're going to use their point slope form of the line. They're going to plug in their pertinent data and come up with their, that is supposed to be a y, it got cut off. And they come up with their equation. So the key to modeling is that you can then use that equation to figure out what's going on when you weren't given the information. Okay, so we're going to assume that the process continues. Okay, so now it said find what happens in year 6. Okay, so at year 0, that was 1998. If we plug 1998, which is year 0 in, we get 18,797. That's our y-intercept. when we let x be 0, we get the y-intercept. And then in 6 years, which is 2004, 1998 plus 6, we should have 12,314 thousand tons of sulfur dioxide. So that's just an application problem of modeling using a linear equation. And that was the end of the PowerPoint. Now I'm going to come back in just a minute with the student guided notes to help you with a few problems there.
On second thought, I'm going to put the extra problems on another PowerPoint or another video because this one has gotten long and it's going to take me a while to upload it.